exponential equations. I have 3 examples. The first example is where you solve with common bases, and then the second 2 examples are where you solve with common logs. And so let's first take a look at this example, common bases. We want to solve for x, and we can see that x is in the exponent. And the reason this is an exponential equation is because we have bases with exponents. And we're going to do common bases here because 2, you could express 64 in terms of the base 2. Because we know that 64, we could change that. 64 is the same as 2 to the 6th power. And if you're thinking, how am I supposed to know that 64 is the same as 2 to the 6th power? This is just where, tip, you should probably get used to some of the common bases and exponents, like 2 squared all the way up to 2 to the 10th, 3 squared up to maybe like 3 to the 10th. You should just kind of have a list in your head of bases 1 through maybe 10 with their exponents. And then maybe some of the higher bases, like maybe even up to like 15 or 20 with some lower exponents like 2 through 4. Because if you have that in your head, you'll be able to know these things. If you don't have it in your head, you'd really just have to do guess and check, which would stink. Okay, but anyway, back to this. So now I see that I have a commonality here where I've got the 2 in the 1/2 and I've got the 2 to the 6th. The 64 has been re-expressed as 2 to the 6th. We're not quite there though with the common bases yet. Okay, so the 2, let's call that 2 to the 1st. Now I need that 2 to be in the numerator just like the 2 to the 6th is in the numerator. Technically it's over a 1. So exponent rules tell me that if I want to move this 2 to the 1st up to the numerator, I'll call that 2 to the negative 1st. When you move something from one level of the fraction up to the other level or down to the other level, you just put a negative on the exponent. So 1/2 is the same as 2 to the negative 1st. And then I still have this x up here from the original problem, so let me attach the x to that exponent. And then 64, instead of being 64, now it's 2 to the 6th, so equals 2 to the 6th. And then that also came with its own exponent of 1/2, so let me just, it's like a times 1/2 up there in the exponent. Now that my bases are the same, 2 and 2, they're equal, so that tells me that since the bases are equal, the exponents are also going to be equal. So I don't need to worry about these bases anymore. They're equal, we know that. Let's just look at the exponents. Let's set those equal and solve for x. So we have negative 1x, or just negative x, equals 6 times 1/2. And now we're going to solve this for x. Well, 6 times 1/2 is 3. So now we have negative x equals 3. Divide a negative out of both of these. That would give you x equals negative 3. So the answer to that problem is x equals negative 3. And that was example 1. Coming up in just a second, we'll do example 2 where the problem will look the same, but we won't be able to get common bases and we'll have to use common logs instead. For example 2, it looks a lot like the first example did. Except for the 13 doesn't have an exponent. It could if we wanted it to, it just doesn't in this example. And then you've got 4 raised to the exponent of x. And x is actually in the same spot that it was in the last example. The difference between this example and the last example is I cannot get a common base between 4 and 13. For example, 13 could not be rewritten as 4 squared. That's not true. Or even if I change them both into base 2, where 4 was 2 squared, 13 doesn't have a base of 2. It's not 2 to the 1st, it's not 2 squared, it's not 2 cubed, etc., etc. So these will not have common bases. So how am I going to solve it? Well, I'm going to need to use common logs instead. And this is one of those things that when I learned this kind of problem, it just blew my mind. Let me pick up my notes off the ground here. I worked everything out in advance, so I wouldn't have to use my calculator too much. But anyway, we can use common logs. If we just add the word log in front of both of these, So now we're finding the log of 4 to the x power and the log of 13. And since these logs don't have bases, we assume them to be the common base of 10. That's why they're called common logs. You probably could use any base, but they just use base 10 since you don't have to write it and it saves you on the writing. So we just add a log to, well, we write a log in front of both of them. And that seems weird and it seems like you shouldn't be able to do that. But you can, as long as you do the same thing to all the terms on both sides of the equation, pretty much anything goes. So it goes here too, where we just put a log in front of both of them. And then you're like, oh, so now we're going to cancel out the log? No, that would just get you back to the same place. No, now we're going to use the power property, which is where it gets fun. Let me write out a little bit nicer what we have so far. So we have log 4 to the x power equals log 13. Now, by the power property, which you learned about in a different video, you know that you can take this little exponent here and drag it out to the front where it'll be multiplication. So now it'll say x times log 4 equals log 13. And now I can isolate the x, which was the goal the whole time, was to get the x by itself. You can see that this says x times log 4, so all I would have to do to get the x by itself is divide by log 4. And then divide by log 4 on this side. And so then you get x equals log 13 over log 4. Or if you were to type that in your calculator, you would get, and I just magically know this obviously, no, I did it before. You would get x equals, I always round to the thousandths, so x equals 1.850. And if you wanted, and that's the answer, you've solved it. If you wanted to know if you did it right, you could always go back and check it. You've got your calculator, so that's amazing. And you could just plug in 1.850 here, and you could find out if 4 to the 1.850 equaled 13. If it did, you're good. If it didn't, then you either did something wrong or you would have no solution. In just a second, we'll look at a very similar example that's just got a few more numbers in it, so you can just see how to do a more complex example with the common logs. Look at one last example of solving exponential equations. This one we're also going to use common bases, but you can see that it's a lot more complex than what we were working with in example 2. That's okay. That's okay. We're going to be fine. First thing we want to do is just try to get the x as much by itself as possible, just using our basic algebra skills. And so let's see, we'd want to move away the 8, the 9, the 10, not so much. If we could, we would, but we can't. But anyway, we want to move away the 8 and the 9. So first thing, we'll move away the 8. We're just going to minus the 8 from both sides. And that's going to give me negative 9 times 10x plus 3 equals negative 73 minus 8 is negative 81. Ooh, that sounds nice. That's going to be a nice, easy number. And then we're going to get rid of the 9. Now we don't want to multiply it with the 10 because we can't, because the 10 is raised to the x plus 3 and the 9 is not. So instead we just need to divide the negative 9 off of here. See, like I said, this is going to make a really nice number. So we're going to have 10 to the x plus 3 equals negative 81 divided by negative 9 is going to make a positive 9. And now you can see we're at the point where it looks just like the common base example I did before. Not the common base, the common log example that I did before. We cannot get common bases because there's nothing I could raise 10 to that would make 9. And there's nothing I could raise 9 to that would make 10. Doesn't even happen. Or even if you changed them into 2s or 3s, you can't make them have the same base and be the same quantities. So you can't do it. So anyway, we're going to do the common logs, which is where you just write the word log in front of both terms. And again, as long as you do the same thing to all the terms in an equation, you should be pretty safe. And so now we have log 10 to the x plus 3 equals log 9. And then we're, just like before, we're going to use our power property. And we're going to take that x plus 3 and we're going to bring it out to the front so it'll be more like a multiplication problem. And so now it's going to say x plus 3, and I want to put that in parentheses really quick, times log 10 equals log 9. Whoops. Okay, and I just put the x plus 3 in parentheses so that way you know that the x and the 3 were kind of connected in a way, and that both of them were being multiplied to the log 10. All right, I've run out of space, so let me kind of erase this top part here and pick up where I left off. I always live in fear that I'm gonna make the whole board come crashing down right in the middle of a video and have to film it again. It hasn't happened yet. It will someday. Make a blooper reel or something. Okay, so anyway, here's where I'm at right now. And we're trying to get the x by itself, so the next thing we would want to do is we would want to get rid of this log 10. You can't distribute it in, that doesn't really make, you could, but it doesn't make sense. We'll just divide it off instead. So that's going to leave us with, and that's going to cancel, x plus 3 equals log 9 over log 10. And we're still trying to get x by itself. Now here, I have the opinion that you could go one of two ways. You could either put this in your calculator and get the decimal and then minus the 3, or if you just want to save all your calculator work to the end just to be more efficient, you could minus the 3 at this point. And that would give you x equals log 9 over log 10 minus 3. Let me erase this from before. And then you would put that in your calculator, which I did earlier today, and you would get negative 2.046. Negative 2.046, that's right. X equals negative 2.046, and that would be your answer. And of course you want to go back with your calculator, plug this in for x in the original problem, make sure it all checks out, but I did and it does. So anyway, that's the answer, and that's how you do this problem. Thanks for watching. As always, if you need more help, my contact information is below in the description. Hey guys, don't forget to like, subscribe, and check out my website at oliviashirleytutoring.weebly.com, where you can schedule one-on-one tutoring and contact me.